Our lecture today concerns mathematical induction, which roughly speaking is a technique that one uses to prove something when one already has a pretty good suspicion as to what the right answer is. Now, rather than to philosophize about this too long, let's tear right into a problem and see in action just what the concept means. Recall that in an earlier lecture, we have proven that the limit of a sum is equal to the sum of the limits, provided, of course, that there are only two terms in the sum. That is, if we have two functions f1 and f2, the limit of f1 of x plus f2 of x as x approaches a is the limit of f1 of x as x approaches a plus the limit of f2 of x as x approaches a. The question now is, how about the limit as x approaches a of f1 of x plus f2 of x plus f3 of x? Now, to tackle a problem like this, we do what is so often done in any mathematical logical procedure. We try to reduce an unfamiliar problem to a familiar problem which has already been solved. Let's see what I mean by that. If this had been only two terms in here that we were adding, we would have known how to handle this problem. So what we observe is that since the sum of two functions is again a function, we can assume that our expression is written this way. Now you see we've reduced our problem to the sum of two functions, namely f1 of x plus f2 of x being one of our functions, f3 of x being another of our functions. We know now what? That the limit of a sum is the sum of the limits if we have two functions. You see, this is what? The limit f1 of x plus f2 of x, you see, plus the limit as x approaches a, f3 of x. But now look what's in this expression over here. This is now what? The limit of the sum of two functions. And you see, we know that the limit of a sum is the sum of the limits is true if we have only two functions. So from here we get to here, and from here we can say what? This is the limit x approaches a, f1 of x, plus the limit as x approaches a, f2 of x, plus the limit as x approaches a, f3 of x. In other words, what we have shown is that the limit of a sum equals the sum of the limits is true not just for the sum of two functions, but for the sum of three as well. And more importantly, the truth for three hinged directly on the truth for two. In other words, it wasn't just that we proved that the formula was true for the sum of three functions. We proved it on the assumption that it was already true for the sum of two functions. And by the way, notice how we may now begin to suspect that this idea generalizes. For example, let's take a look over here. Suppose I now said, how about the limit as x approaches a, and we'll now take the sum of four functions, f1 of x, plus f2 of x, plus f3 of x, plus f4 of x. See, what about something like that? And again, we argue the same way as we did before. We say, you know, if we had only had two functions in here, and this gives us the hint to do this, see, we do know that the limit of the sum is the sum of the limits if we have only two functions. You see, now I could write this as what? It's the limit of the first one as x approaches a. But what is the first one? The first one is the function f1 of x plus f2 of x plus f3 of x plus the limit of the second. The second now you see is f sub 4 of x as x approaches a. Now you see our previous case told us what? That the limit of a sum is equal to the sum of the limits if you have the sum of three functions. That's exactly what we have over here. And now you see we can say what? Ah, this is the limit of the first as x approaches a plus the limit of the second as x approaches a plus the limit of the third as x approaches a plus the limit of the fourth as x approaches a. In other words, what have we done now? We've shown that knowing that the limit of a sum is the sum of the limits was true for a sum of two functions and of three functions. We've shown inescapably that the same result holds for the sum of